What up, players? 2.3 higher order derivatives and product rule, Calc BC. Homework page is right there. Hopefully you're not mesmerized by the background and wherever I am right now, because it's amazing. Hopefully, well, you might have seen as a kid, like, a show or played a game like Where in the World is Carmen Sandiego? So I'm going to be playing that for the foreseeable future, and each video I'm going to try to be somewhere else in the world. I don't know, kind of surprise you, maybe surprise me too, I don't know. Alright, so high order derivatives of functions, equations of acceleration from a position function, and then derivative of a function using the product rule. Okay, so higher order derivatives, here we go. You can take a derivative as many times as you want until you get to 0. You can keep doing that. So y prime was first derivative, double prime, triple prime, fourth prime, or nth prime is you can take with the nth derivative. These are just 4 different ways to write it. Yeah, I'm not gonna spend too much time with that. So example, we'll do some examples, might as well, I don't know what to tell you. Find the third derivative. So the first derivative is 3x squared. The double derivative is 6x, and then the triple derivative is 6. Fantastic. This now is the fourth derivative. This is just another way to write fourth derivative. And this is already the first derivative. So dy dx, remember, that is the derivative. Okay, so now we just got to find the third one. So d squared y over dx squared is what? 20. Oops. Oh, that looks like a duck or something. 20x to the 3 minus 3, and then d to the third y over dx to the third is 60x squared, and then d to the 4 y over dx to the 4 is 120x. Okay, this one here to the fourth, so this is just the original function. So y prime is equal to cosine of x, y double prime is equal to negative sine of x, y triple prime is equal to negative cosine of x, and then y to the fourth, or to the fourth there, is equal to sine of x. So the fourth derivative is the same as the original function. Pretty awesome there. Okay, sweet. Acceleration is the derivative of velocity and the second derivative of position. We already know that from last year probably. So it goes position, it goes velocity, and then it goes acceleration. Remember, this is s of t, v of t, and then a of t. This is basically your original function is f of x, and then f prime, and then f double prime. Okay, should be pretty easy there. The position of a particle is given by the equation x of t. So I know we use s of t for position, but we also, another one we can also use is x of t. That's just another way we can kind of write it. 4t to the third minus 3t squared plus 5t minus 1. Find the acceleration of the particle when t is equal to 3. So x prime of t is really v of t, which is really 12, okay, yeah, 12t squared minus 6t plus 5, which then I want to go to a of t. I want to find the acceleration. So that's 24t minus 6. But I want to find it when t is equal to 3. So I'm just going to do a of 3 is equal to 24 times 3 minus 6, which is 72 minus 6, which is 66. Boom. Fantastic. So a of 3 is equal to 66. Okay, we don't know the units, I don't think. No, you know, units there, so we can't put units on that. But say if t was in time and x of t was in feet, then this would be 66, how do I want to write that? Feet per second, right? Or feet per second squared. That's how we would write that. So the velocity of a particle is given below. Determine the acceleration of the particle when t is equal to 5. So what we can do is, because we have t is equal to 5, we know it's right in here. So we're going to use these two values and we're going to approximate it. Okay? This is still an approximate value because we don't know what the exact value for 5 is. We can use 4 and 6 as an approximate value. So we can say, okay, 16 minus 10 over 6 minus 4 is 6 over 2, which is 3 feet. Oh, I'm sorry, this is meters, not 6 over 2 is equal to 3 meters per second squared, or meters per second Okay? So remember that acceleration is it 2 L's, 1 L? Oh, it's only 1 L. It's 2 C's though. Is the slope of velocity. Okay, remember that. Again, we know that anyway, hopefully, but that's basically what we're doing there. Okay. What else? That was it, I believe. There. Product rule. The product of two differentiable functions is differentiable itself. So what that means is, if I have x squared and x to the 4th, okay, they're both differentiable, so that means when I multiply them and I get x to the 6th, those are still differentiable. So that's what it's saying. If f and g are differentiable, then f times g is also differentiable. And then to find the derivative of the product, if I use this rule, right? Now, last year, we used u's and v's. So u and v, so we would say u prime v plus u v prime. You are more than welcome to use that same analogy or use that same notation. That doesn't matter. I don't really care. So in this case, the derivative of the first function times the second plus the derivative plus the first times the derivative of the second. So it's just u prime v plus u v prime. So in this case, I'm going to say u is equal to x squared. Okay, and then v is equal to 2x minus 2. And so u prime, so it's 2x, and then times v plus u times the derivative of that, which is 2. So I should get, let's multiply it out, what the heck, right? 4x squared minus, 4x squared minus 4x plus 2x squared, so 6x squared minus 4x. Now, if you were to multiply this out and distribute it out, you get 2x to the 3 minus 2x squared, which then if I took the derivative of this without using the product rule, because I didn't need to, that's just simple power rule, I get 6x squared minus 4x. So I get the same answer both ways. Okay, make sure we notate that this is the derivative of f. But regardless, you get the same answer. Now, for part number 2, or for example 2, you're not going to get the same answer because one's a trigonometric, one's a polynomial, so you're not going to be able to do that. But with example 3, you could do that if you wanted to. You could FOIL them out, separate, or put them into one simple polynomial, and then do your product rule from that. That's up to you. In this case, we're going to say u is 3x to the 3rd, and we'll say u prime is 9x squared. And then we can say that, v is equal to sine of x, and then v prime is equal to cosine of x. Hopefully remember the trigonometric derivatives so far. We haven't gotten to tangent and cotangent, all that other stuff, but these two you should already know. So then remember it's u prime v, so it's these two, and then those two, so it's 9x squared sine of x plus 3x to the 3rd cosine of x. And there's your derivative, and I'll make sure to have proper notation. This one, I'm going to say u is equal to x to the 3rd minus 4, v is equal to 2 minus 3x, v prime is equal to just negative 3, and then u prime is equal to 3x squared. So then, remember, it's u prime v, and then that. So I'm going to distribute that right away. So it's going to be 6x to the 2 minus 9x to the 3 minus, or yeah, we'll say minus because it's really plus, but this is a negative. So 3x to the third, and then plus 12. Alrighty then. And I guess we can combine those, you know, if you wanted to. So negative 12x to the 3 plus 6x squared plus 12 is equal to f prime of x. There you go. Okay, so now the product rule can be generalized for any number of products. Okay, so for any number of products, well, if I have 3 different functions, okay, like f, g, and h, I can basically say that the derivative would be original, derivative, plus original, derivative, plus, and then now it's going to be f prime, g, and then h. So you can see that the derivative of each of these is only in one of them, and then everything else is the original function, right? So we can have f, g, h, i, j, k. We can have 26, 38 million different functions, doesn't matter. And then we can very well find the derivative of all of those using this simple generalization. The position of a particle is given by x of t is equal to t squared minus 4t times cosine of t. Find the acceleration of the particle when t is equal to pi over 2. So position of the particle is the original function. So this is original, or f of x. And then acceleration is f double prime. Okay, so we got to find v of t, which is equal to, and this is u and then v. And so u prime is what? 2t minus 4. V prime is equal to negative sine of t. So v of t is u prime v, so it's 2t minus 4. All of that is times cosine of t, plus, and really it's a minus, we'll say it's t squared minus 4t times sine of t. The negative just came over here. Now we got to find the derivative of this. So that's v, so now we got to find a of t, because that's what we ultimately want. So we'll say this is u again, this is v, this is u, and then v. So we're going to split this into 2 separate derivatives, because our u's are going to be different, right? So our u prime here, so we'll say u is equal to 2t minus 4, u prime is equal to just 2, v is equal to cosine of t, and then v prime is equal to negative sine of t there. U prime is equal to 2t minus 4. U is just equal to t squared minus 4t. V is equal to sine of t, and then v prime is equal to just cosine of t. So now let's put that all together to find the derivative here. So u prime is 2 times cosine of t plus, well, this is a minus, so it's a minus. We'll say sine of t times 2t minus 4 minus, because this is a minus now, so that carries through. And then u prime times v, so it's 2t minus 4 times sine of t plus, because we're back now. Well, actually it's a minus because we got to distribute that through, right? So it's really another minus. And then now v prime u, so cosine of t times t squared minus 4t. And that stinks. That's a lot of work. We're not done yet. Why not? Well, because we didn't plug in pi over 2. So we have to plug in pi over 2 here. So when I plug in pi over 2 of cosine is just 0, so 0, that's 0. Minus, that's 1 times, pi over 2 times 2 is just pi, so pi minus 4. Minus, That's pi minus 4 as well, because that's just 1. And then cosine of t is 0. 0 times out of 0 minus 0, so that doesn't really matter. So we get minus 2 times pi minus 4, or negative 2 pi plus 8, which is equal to a of pi over 2. Okay, that's a lot of work right there. That really is a lot of work, but there's really no fast way to do that. The only fast way to do that is if you actually were able to use your calculator and calculated the derivatives using the Math 9 or Math 8 tool. You know, you'd have to probably calculate the first derivative, which is this, and then plug this into Math 8 and evaluating it at pi over 2, and it would give you negative 2 pi plus 8. Probably, I don't know if it would give you that. It might give you like negative 6 point something or negative. It might actually multiply it through. I'm not actually sure. But that's one way you could potentially do that. Okay, that's this video done. See you in the next one. Deuces.